So once again, physics paper 3, that is heat and thermodynamics, and the next topic is refrigerator after completion of heat engine. Okay. So here, what is refrigerator? So before that, we shall have some discussion about refrigerator. The heat can be transferred from one place to another place by three ways. Okay, you know very well that you have learned these things in earlier standards. The heat can be transferred from one place to another place by three ways. The first one is radiation, the second one is conduction, and last one is the convection. Okay, so in nature, all the processes occur by heat transfer from a source at high temperature. Okay, it is the condition that the source of heat or energy should be at high temperature. Okay, source at high temperature to a sink at lower temperature, sink at lower temperature. Okay, so here we shall define convection mode of heat transfer. That is, convection is the transfer of heat by mass motion of fluid from region of one space to another space. Okay, you know very well that water or all liquids get heated due to the process of convection. Okay, conduction is possible in all solids, convection is possible in all liquids, and radiation is possible everywhere, especially through gaseous medium. The fluids may be gas or liquid. For convection, the fluid may be gas or liquid. Flow of hot air and hot water in heating system are the familiar examples of convection. Okay. However, it is possible to transfer hot air or hot water from cold region to hot region of space by doing external work on the system. Okay, the last line is very important as far as the topic, that is refrigerator, is concerned. However, it is possible to transfer hot air or hot water from cold region to hot region of space by doing external work on the system. Okay, so this last sentence of this slide has idea about the refrigerator. So from this word, the heat, to this one, convection, this is according to our earlier concepts of heat and thermodynamics. Okay, but after studying these concepts, we can form this last statement, and from that idea of refrigerator comes. Okay, so refrigerator is a device which absorbs heat at low temperature, that is cold place, and rejects heat at higher temperature, that is hot place, with the aid of external work. So this is the simple definition of refrigerator. Refrigerator is a device which absorbs heat at low temperature and rejects heat at high temperature, okay, with the aid of external work done, or simply external work. So this is the definition of refrigerator. Thus, refrigerator maintains low temperature than the surrounding by continuous extraction of heat from the required place. The action of refrigerator is opposite to that of heat engine, that is Carnot's heat engine, where heat is absorbed at high temperature and rejected at low temperature by performing mechanical work at the output. Okay, so this is the basic glance about the refrigerator with the discussion of its definition. So you know very well that according to second law of thermodynamics, if you are talking about refrigerator, before that, this is the definition, that it means refrigerator absorbs heat at low temperature and rejects heat at higher temperature. Okay, so before that, you know very well that, or it is a common observation that whenever you are in the house and the temperature of atmosphere is 42 degrees Celsius, okay, temperature of atmosphere or temperature of surrounding to our home, if it is 42 degrees Celsius, and if the room temperature is, say, for example, 27 degrees Celsius, generally we used to choose room temperature as 27 degrees Celsius. So obviously heat flows from higher temperature to lower temperature, so that thermal equilibrium is achieved. Okay, so these are the arrows, yellow arrows indicating the flow of transfer of heat. That is the radiation. Okay, this is achieved till the thermal equivalence or thermal balance between the two medium, that is the home and atmosphere, is maintained. Now suppose temperature of atmosphere is 19 degrees Celsius. Okay, temperature of atmosphere is 19 degrees Celsius, and the room temperature is now heated and it is 37 degrees Celsius. Then obviously heat flows from home to atmosphere, so that home will get decrease in temperature. That is, whatever mean temperature is there, mean of these two, that is 19 and 37 degrees Celsius respectively, the mean temperature between these two is achieved. Okay, so earlier one and this one, these two are the examples according to second law of thermodynamics. Now again, if you talk about second law of thermodynamics, certain principles are there for cooling of the refrigerator, or whatever cooling action in the refrigerator is there. Some general principles in case of cooling in refrigerator and in air conditioning system are available. Okay, so the basic principle behind both the systems is, as I told you earlier, the second law of thermodynamics. Okay, so according to this law, the statement of this law is over here: heat cannot flow, heat cannot flow from a colder body to warmer body without aid of an external agency. Okay, I shall read it once again: heat cannot flow from colder body to warmer body without aid of an external agency. This law states that the direction of heat flow. Okay, so here important word I have used, the direction of heat flow. Okay, or it is also called as arrow, thermodynamic arrow. Okay, if you read Halliday Resnick book, that is Fundamentals of Physics, written by Resnick, Halliday and Walker, there they have used the direction. Okay, direction of heat flow, that is thermodynamic arrow. In the refrigerator or in air conditioning systems, the external work is done on the system so as to transfer heat from lower temperature region to higher temperature region. Okay. Now, in both the equipments means, this is again general principle, in both the equipments means in the refrigerator and in AC also, air conditioning system, which may be present at our home, in both the equipments, conversion of liquid into gas by absorption of heat and conversion of gas into liquid by rejection of heat are utilized for the development of the system. Okay, so the first sentence of this slide is very important in case of refrigerator and air conditioning system. In both the equipments, conversion of liquid into gas by absorption of heat and conversion of gas into liquid by rejection of heat are utilized for development of the system. So basically, the effect of cooling is made by the adiabatic expansion of the compressed gas by doing external work done. So overall, all these reverse Carnot cycle followed to transfer the heat flow from lower temperature region to higher temperature region. Okay, so here you can write a sentence that a refrigerator or air conditioning system works on the principle of reverse Carnot cycle. Okay, actually this reverse Carnot cycle, the word is very important. Reverse Carnot cycle is followed in case of refrigerator and air conditioning systems. Okay, so after that, the first point or the first cycle is refrigeration cycle. Okay, so in case of refrigeration cycle, or it is also called as reversed Carnot cycle, in the refrigeration systems, a reversed Carnot cycle is adapted so as to get maximum coefficient of performance, COP. Okay, COP stands for coefficient of performance. Okay, so this is, that is reversed Carnot cycle is adapted or followed so as to get maximum coefficient of performance, that is COP. In earlier case, that is in case of all the heat engines which we have studied, that is the first one was the Carnot heat engine, then second one Otto engine, and the third one diesel engine. We have calculated efficiency eta. Okay, so here refrigerator and refrigeration cycle and air conditioning system all are working or following reverse Carnot cycle. Hence, the reciprocal of efficiency is equal to coefficient of performance. This is not modulus of rigidity. Okay, eta here, eta is coefficient of performance. All are sleeping. Eta is efficiency, and a reciprocal of efficiency is COP in case of refrigeration cycle. So the second point is the refrigeration cycle can be understood from the following figures. So the first one, in case of refrigeration cycle, okay, two important parts are there at the beginning. First one, we have a condenser as shown in the diagram, then evaporator, compressor, expansion valve. Okay, so if we start from the condenser, in case of condenser works to condense the liquid. Okay, that is whatever air or gas is there inside the condenser which is cooled, or whatever water is there, that water is cooled inside the condenser. So the basic thing here is that conversion of one state of matter to another state. So if you're talking about air, then air can be converted to liquid or water. Okay, and both are, that is air at the beginning, air or gas is cooled to transform from air to water, and again the water is cooled to a minimum possible lower temperature. Okay, then this water cooled mechanism, or whatever liquid is there inside the condenser, that is known as liquid refrigerant. Okay, and as the arrow is indicating, that liquid refrigerant, that is cooled liquid, is taken in inside the expansion valve, and due to expansion valve, as the name is suggesting, the expansion of liquid refrigerant inside the expansion valve takes place. And here we have, from expansion valve to evaporator, we can observe the mixed phase of liquid and vapor which is inside the channel, or whatever tubings are there inside the tubings or channel of the refrigeration cycle. So when the mixed phase of liquid and water, that is, they contain both some amount of liquid and some amount of vapor. Vapor transformation is there due to expansion valve. Okay, so the mixed phase is then taken inside the evaporator, and whatever heat is there, whatever heat is absorbed by the refrigeration cycle from the substance which were kept to be cooled inside the refrigerator, whatever heat is there, absorbed heat is used to evaporate the liquid, that is the mixed phase of liquid and vapor inside the evaporator. So once again, due to heat absorption, evaporator evaporates the total liquid into vapor. Okay, so at the outlet of evaporator we can observe vapor, and again the vapor is transformed or transferred through the tubings towards compressor. Then compressor compresses the vapor to form a liquid again. Okay, and then condenser condenses, suppose mixed phase of vapor plus liquid is there. So whatever liquid and vapor both are there, whatever vapor is there, that vapor is condensed to form a liquid inside the condenser, and again the liquid refrigerant is used or transferred to expansion valve, then evaporator, then compressor, and then condenser. So this is the course how refrigeration cycle goes on. Okay, so after that, this is also flow chart regarding compressor, condenser, evaporator, expansion valve, that is again refrigeration cycle. Suppose if we talk about compressor, in case of compressor, it reduces volume and creates high pressure gas, causing the temperature to rise. Okay, and whatever gas is there, hot gas obtained from outlet of the compressor, it is again transferred to condenser. Okay, it is also known as, or also called as, heat exchanger. Condenser is also called as heat exchanger, where hot gas is cooled by air or water before being condensed to become a hot liquid. So after condenser we have hot liquid, which is transferred to expansion valve. It is also called as metering device, that is, which metering means which measures the amount of expansion of volume. Okay, so they consist of capillary tubes. In case of expansion valve, the process occurs, that is, hot liquid cools due to pressure decrease resulting in cold refrigerant. Now, here is the opposite to earlier step, that is hot gas, and the opposite is cold refrigerant. Now this cold refrigerant which is obtained after expansion valve is taken inside the evaporator. So here evaporator works to cool refrigerant chills equipment as it vaporizes, turning back into a gas as it draws heat away from the refrigerator's contents before exiting the evaporator. So here at the outlet of evaporator we have obtained gas, and which is opposite to the earlier step, opposite step, that is hot liquid. And again this gas is taken inside the compressor, that is compressor reduces volume and creates high pressure gas, causing the temperature to rise. Okay, so in this way, again compressor, condenser, expansion valve, and evaporator, that is, if at the beginning compressor has started working, then condenser, then third one expansion valve, then fourth one evaporator, and then again first, that is compressor. Or if condenser has started working initially, then first will be the working of condenser, then second expansion valve, third evaporator, and the fourth one is the compressor. Okay, and again condenser. So in this way, 1 2 3 4, whatever it is there, 1 2 3 4, 1 2 3 4 1, 1 2 3 4 1 is followed in case of refrigeration cycle. So now this is the actual refrigeration cycle which is inside the refrigerator. So, say please wait for a few moments. I shall mark your attendance. So okay, so this is the basic cycle regarding refrigeration. Okay, so it is also called as vapor compression cycle, which is there in our syllabus. Actually everything is there whatever I have discussed now in our syllabus, but this is the diagram which you can draw if it is asked. Okay, so we shall discuss this slide only, and after that we shall stop for today. So here is the title, vapor compression cycle. So here, as you see carefully, that it consists of compressor, then opposite to compressor expansion valve, then evaporator, and then the opposite to evaporator is the condenser. Okay, so suppose if you start from the evaporator, evaporator is nothing but the cold reservoir heat source. At the bottom, as it is mentioned, it is cold reservoir heat source. Okay, so here Q stands for energy, that is cold, that is cold reservoir. Even if it is having certain amount of heat, it is transferred at 3000 watt from evaporator to compressor. Okay, so they have measured the amount of heat even if cold substance is there, which is about 3000 watt in case of vapor compression cycle. So after evaporator, whatever liquid is there, which goes towards compressor through the first valve. Okay, which is not capacitor, it is valve, first one, and after one capacitor like symbol is there, but it is not capacitor. Please note that it is not capacitor, it is certain valve. Okay, so after evaporator, whatever vapor is there, that vapor is taken inside the compressor. So compression of vapor takes place at 1500 watt. So whatever work done is there, that work done is done by the compressor, and the total work done is known to be W net. Okay, that is total amount of work done. Then the compressed vapor is taken inside the condenser. Again I have written over here vapor. Okay, so 2 or second is the another valve through which vapor is taken inside the condenser. Now here condenser condenses the liquid. Okay, actually it condenses the vapor to form liquid, and due to condensing action of the condenser, the heat, that is 4500 watt, is transferred. Okay, or it is absorbed from the substance, and it is transferred to the heat sink, that is hot reservoir. Okay, that's why it is shown by red arrow, that is Q hot. Okay, hot reservoir, it condenser absorbs or takes heat away from the substance, and the amount may be 4500 watt. So due to condensing action, whatever vapor is there, vapor is transformed to liquid, which is again taken from third valve to expansion valve. Okay, so after expansion valve, again when the liquid passes through expansion valve, this one, then again which is passes through the fourth valve inside the evaporator. So through fourth valve, we have a combination of liquid and air, sorry, vapor. So combination of liquid and vapor passes through fourth valve inside the evaporator. So where which is evaporator, which is nothing but the cold reservoir heat source, okay, which takes the heat around 3000 watt from the vapor. Okay, and again the evaporator transfers the vapor to compressor, then compressor to condenser, then condenser to expansion valve, and then expansion valve to evaporator. Okay, so in this way, vapor compression cycle works. Okay, so this is the typical diagram, which is very simple diagram for your understanding. So here also we have condenser, maybe water cooled or air cooled. If we start from the top left corner of the slide, then at the bottom cold air, which is evaporator, and opposite evaporator we have a condenser. Then at the top, middle top, compressor. Then here phase, that is vapor. Again here is vapor phase. Then opposite to compressor we have expansion valve, and inside the expansion valve liquid reaches, and through, that is at the outlet of the expansion valve, we have liquid plus vapor. So this is the diagram, which is very simple to understand and to draw in the examination. So this is a typical single stage vapor compression refrigeration. Okay, so this is the vapor compression refrigeration cycle. So this is the PV diagram of refrigeration cycle. So we shall stop over here and we shall discuss the PV diagram of refrigeration cycle in the next lecture. So if you have any doubts, you can ask.